The objective for today's experiment is to determine the effect of temperature on enzyme activity. The enzyme that is chosen for the purpose is trypsin, and the effect of this enzyme on milk will be observed. It is seen that trypsin coagulates the milk. The protein which is found in milk, that is casein, is broken down into small peptides in presence of trypsin. Along with these two things, we will be needing test tubes, test tube holder, graduated cylinder, dropper, wash bottles, etc. In order to see the effect of temperature on enzyme activity, water baths at different temperatures have been maintained. There is a water bath at 0 degree, 20 degree, 40 degree, 60 degree and at 80 degree. The time taken in the experiment will be recorded with the help of a stopwatch. To start the procedure, first of all, take two test tubes. In one test tube, make a mark approximately in the center of the test tube. You can make a ring mark or a cross mark, something to identify, and we are going to fill this test tube with 5 ml of milk. In the other test tube, which you can mark as T, trypsin, we will add 5 ml of trypsin. So, first I have taken this marked test tube and I am going to pour 5 ml of milk sample to it. As you can see, the milk sample has been poured in the test tube, and now we will take another test tube and fill it with 5 ml of trypsin. We have used graduated cylinder to measure the volume. So, this is our 5 ml of trypsin. Now, since we have 5 water baths, we have prepared 5 set of milk sample and trypsin. As you can see, we have prepared 5 set of milk samples containing 5 ml of milk in the test tube and mark these test tube with the temperature of the water bath. Similarly, we have taken another 5 test tubes and have put 5 ml of trypsin in these test tubes. The next step is to keep milk and the trypsin in water bath for 5 minutes so that they attain the temperature of the water bath. So, this is a water bath maintained at the temperature of 60 degree. Now, we are going to place the milk sample and trypsin in the water bath for 5 minutes so that they attain the temperature of 60 degrees. We have taken this milk sample which is marked with 60 as the temperature of the water bath, and this is another test tube with 5 ml of trypsin. We are now going to place these two test tubes in the water bath for 5 minutes. This is in order to attain the temperature of the water bath. As you can see, the test tubes have been placed in various water baths to attain the temperature of the water bath. After 5 minutes, we will take out these test tubes and add trypsin to the milk sample. After 5 minutes, take out the 2 test tubes. You can see the milk sample and the trypsin both have attained a temperature of 40 degree, and now we are going to mix the trypsin sample in the milk. As soon as we add both the samples, just swirl and mix it. And start the stopwatch. What we have to note down is when the curdling of milk will take place, the solids will start settling down, and when it reaches this mark, we have to record the time taken. We will replace the mixed sample back in the water bath. As you can see, the two solutions, milk solution and the trypsin, both are at 60 degree. Now I am going to add trypsin solution to the milk. As soon as I add it and mix it, we are going to start the stopwatch. So you can see the trypsin is being added to the milk. We will swirl it a bit so that it is mixed. And as soon as it is mixed, we are going to start the stopwatch. We have to record the time taken to become transparent. And now I will put this sample back in the water bath. As you can see, all the milk samples have been mixed with trypsin and the time is being recorded. The curdling of milk has taken place, you can see, in 80 degree, and we have recorded the time. Likewise, we are going to record for all the samples. Both for 0 degree and 20 degree C, we have not observed any major changes. This is 0 degree C sample, and you can see there is no curdling of milk that has taken place, no settling of the casein protein that has taken place. Similarly, in the 20 degree C sample also, you cannot see any reaction that has taken place. Maybe it will take more time for this sample to curdle and casein to settle down. For the sample kept at 60 degree, you can see the curdling of milk has taken place. The top part has become transparent. You can see casein protein settling down, and we have noted down the time taken in curdling of the milk. For all the samples, the time has been recorded. What is observed is in 0 degree, there is no change. There is no curdling of milk, no settling of casein protein, and almost no change is observed for 0 degree temperature. For 20 degree, also we have observed there is hardly any change for 20 degree. if you look really closely, you may see some amount of curdling, but the time taken is very, very long. As for 40°, you can easily see a lot of curdling has taken place, and in fact the time taken was least at the 40°. When the curdling process started, the time recorded was the smallest. Similarly, at 60° and also at 80°, there is curdling of milk, but the time taken was slightly more than what was observed at 40°. So, we can say that at 40°, the time taken to start the curdling of milk was the shortest. With this, we come to the conclusion that at 40°, the time taken was least, and then it was followed by 60°, 80°, whereas at 0° and 20° C, we hardly saw any change in the milk sample.